Hi guys, let's go ahead and get started on this review. Again, I'm hoping that at this point you've gone through and tried everything that you could do. You focused on the ones that you know, and now you're just coming back to get some help with the ones that you have questions on. All right, so the first thing I want you to pay attention to is actually reading the instructions. So make sure that you're reading them so you know what this test is asking for. Don't assume that what was number 1 here is number 1 tomorrow, okay? So we're going to go ahead and talk about writing each log in exponential form. This is when that one day in class when we were playing grudge ball, we talked about how can I write it from one form to the other, right? So first thing we're going to do is we're going to look for the base, and then we're going to look for the exponent and look for the argument. We need to be able to identify all three pieces. Number 1, 2, and 3 are in log form. So when I have something that is in log form, that's when we know it has the term log with it. And then we're going to convert that into exponential form. Okay. Another thing that I wanted to point out here is that remember that when we have log base e, that is the same thing, log base e of x, that is as ln of x. All right. So ln has a base of e. So let me try this. If I have log and the base of some number, then the base, here on this one, the base is whatever the number is. Okay, so the base here is whatever b is. If I have log of x and they don't tell me the base, then on this one we know the base is understood and it is 10. And then for the last one, if they give me ln of x, this one here, the base is understood to be e. E is an irrational number. All right, so on number 1, we are going to convert this into exponential. It is a natural log, so natural log has a base of e. And then the argument and the exponent, the answer, they will switch place. So I have e to the 8th power is equal to x. And that's all we're doing with these ones. We are converting from one form to the other. Okay. All right, number 2, we have a natural log, so that means my base is going to be e. The argument is x minus 5, and the answer is -4. So the argument and the answer here are going to switch place. So I will have e to the -4th power is equal to x minus 5. Right, on number 3, this one is not natural log. This one is a log with a base of 3. So I'm going to take the base 3, and these two here will switch locations when converting forms. So 3 to the 5th equals x. Now for number 4 through 6, now we're going to have an exponential form, and we are going to convert it into log form. Okay, sorry about that. So make sure again that you're reading those instructions. We're going to write it in log form, so that means I start out in exponential form. So start in exponential form, turn into log form. If it's a natural log, if it has log or if it has a base of e, it's going to be a natural log. So we're going to replace that with ln. Okay. All right, this one here, the base is 1/8. The exponent is -2. So let's go ahead and rewrite this one with the term log. So log to the 1/8 base of 64 equals -2. E to the x equals 12. Well, if you thought about it in the sense where we have log e of 12 equals x, Log E is our natural log, so we can just write ln of 12 equals x. All right, here again, I have a base of e, so I know I'm going to be using a natural log. The exponent is x minus 7. It's everything that is there, so we're going to take that and swap it with 9. So ln of 9 is equal to x minus 7. All right, so that is from numbers 1 through 6. Again, make sure you're reading the instructions for each of these. All right, for 7 through 9, we are going to evaluate. Evaluate means now there's going to be that equal sign that we've got to look at. So evaluate, and we are going to use the change of base formula. Now, in our calculators that I have here in class, just remember when we enter it with the value before the phrase log, okay, before the key that says log on it. So anytime we have a change of base, we are doing log of the argument divided by log of the base. So number 7, I'm trying to figure out what does it equal. So I'm going to take the log of the argument. It's log base argument. So the log of the argument divided by log of the base. Now this one here, when you use your calculator, we would type in 4 log divided by 11 log, and then we have to hit the equal key. And rounding to the 10,000ths place, this would be tens, this would be hundreds, this would be thousands, and that would be 10,000ths. And that's where we get our 4 places after the decimal. Okay. All right, on number 8, again, using change of base on this one here, I will have log of the argument. So log of 4/5 divided by log of the base. I'm actually going to change these to about because I know I'm rounding. All right, so in our calculators, we have 4ABC5 for the fraction, log, divided by 7 log, and then hit equals. Again, to the 10,000ths place. And since here is where we're stopping, we can go ahead and round on that one. So our answer is negative 0.1147 10,000ths. All right, number 5, that's a natural log. So that means that it has base E. Our calculator actually has a button that shows ln, okay? So we are just going to do the natural log of radical 5. So I'm going to go ahead in my calculator and type in 5 radical so I can get the square root of that value. That gives me 2.236. And then I'm going to hit ln. So this here is about 0.8047. Okay. So on these ones here, if you get stuck in class, remind me how to, if you're like not sure where that button is, remind me and I'll show you where to find the button. I won't tell you when to use the button, but I will show you where to find it. So what if I had ln of 13? Then you type in 13 ln, and that would give me 2.5649. Okay. What if I had the natural log of 1/2? Well, then in the calculator, I would do 1 divided by 2 ln, and I'd get negative 0.6931. What if I had ln of just 5? Okay, you would type in 5 and ln, and it'll give you that value. All right, so let's go on to number 10 on this one. we are going to be expanding. Now, when we were talking about expanding, we referred to it like, hey, this is like similar to distribution. Okay, I need to know how many terms are inside this argument here, and then know that I'm going to have each of them with the beginning of log base 4. Okay, so looking at this, a common mistake that I saw today is that people were giving me this here. Log 4 of 5x to the third minus log 4 of w to the fourth. Now, you're on the right path, but I need you to see something here. 5 has its own exponent. 5 is to the power of 1. X is to the power of 3. So 5 and x to the third, they still need to be separated. They need to be broken apart just a little bit further. Okay? So here on this one, when I think of distribution with these, I think of log to the fourth is going to go with 5 to the first power. Log to the fourth is going to go with x to the third power. And log to the fourth is going to go with w to the fourth power. So writing this out in expanded form, I have log 4, 5 to the x. That's part of the numerator. So I know that this term is positive, even though I don't write positive right up front because it's understood. Then I have log base 4, x to the third. This one's also positive because it's in the numerator. This time I need the sign, okay, because it's not the leading term with a positive. Then I have log base 4, w to the fourth, and this one's in the denominator, so it is a negative. All right, now on each of these, I need to have the log, the base, and the argument. So I've got log, didn't mean to grab that one, log, base, argument. Oh, I totally messed that up. Let me back up there. I'm not even sure why I put 5x to there. That should have just been 5 to the first. I know, I got somebody on that one. Okay, so it should be log base 4 of 5, not x. I just said not to make that mistake, and then I made that mistake. Okay, so this should be log 4 of 5 plus log 4 of x to the third minus log 4 of w to the fourth. Okay, sorry about that. All right, now on this one, log base argument, log 4 of 5 plus log 4 of x. That third up there is a power. I'm going to have to do something with that. And then I have log 4 of w, and that 4 there is a power, so I'm going to have to do something with that. This is where we use the power rule. 3 is going to be replaced right here in front of the log. 4 is going to be replaced right in front of its log, or be rewritten. Okay? So we will have log base 4 of 5 plus 3 times log base 4 of x minus 4 log 4 of w. Okay, that's what we practice with expanding. So we're just going to go that far there. Okay, all right, now when we go to condensing, it's think of the opposite of distribution. So this time we are going to be, okay, wait a minute. I have a blank page here. So now instead of distribution, think of looking for the opposite of distribution, which is the greatest common factor, or the GCF. So I want to write this in a single log. I want to find out what they have in common so I can factor it out. So I'm looking at each of these and I said, oh, they all have ln in common. ln, ln. They all have natural log in common. But this one has a 4 in front of it. So I can't have that 4 there. This one has a 3 in front of the natural log. I can't take out the idea of natural log until I move that first. So I'm going to take that to be the power rule. So 4 is going to be the power on 2. 3 is going to become the power on y. So I'm going to have ln of x plus ln of 2 to the 4th power minus ln of y to the 3rd power. Now that they all start with natural log, now I can go ahead and condense it. So I have natural log. X is a positive term, so that's going to be x. Then I've got 2 to the 4th, so times 2 to the 4th. And then negative term for y to the 3rd. So because it's negative, I know that it's going to go in the denominator. Okay. So I will have natural log 2 to the 4th is 16, so 16x over y to the 3rd power. All right, so let's go on to problems number 12 through 15. These are the ones where we are solving. Okay, these are a lot of the ones that we practiced in class today, or that were around the classroom. So when you are solving, you need to determine whether it is in exponential form or log form. Okay, when we're solving, we need to round to the nearest 10,000th place if it's, or to the 10,000th place if it's not even. And if it's a log, we're going to check for extraneous solutions. Okay. All right, number 12. When I'm looking at number 12, this one is exponential. So when it's exponential, I need to have the base and the exponent. Anything extra, I need to move. So just the base and the exponent is all I want here. So here, the base is beneath the exponent, so the base is 9. The exponent is 2x. So that 4 over there, it's extra. I need to move that for right now. So I've got to divide by 4. Whatever I do to one side of the equal sign, not the same side of the equal sign, but to one side of the equal sign, I do to the other side of the equal sign. So then I've got 9 to the power of 2x is equal to 17. Now 9 and 17 are not a common base. They do not have a common base, so I can't cancel those off. So I'm going to have to convert it to log. Remember, the inverse of exponential is log. If you get stuck on an exponential, it's likely that you have to convert it to a log. If you get stuck on a log, it's likely that you need to go back and convert it to exponential. This, again, is like numbers 4, 5, and 6. Exponential turned into log. So I have log 9. These two here swap places. So log 9 of 17 is equal to 2x. So log 9 of 17 is not a value that we can think of. So we're going to go ahead and, or that we can evaluate easily. So we're going to go ahead and do change of base. So log of 17 divided by log of 9 is equal to 2x. We're going to need our calculator for this one. Okay, so you're going to do 17 log divided by 9 log, and then don't forget to hit the equal sign. So we've got 1.28945. I'm not going to round just yet. Remember, we don't round till we're all the way done. To get x by itself, I'm going to divide by 2, and I get that x is equal to 0.6,447 10,000ths. Okay, I just ran out of room there. But for that one there, you have exponential, get the base and the exponent by itself, convert it to log, and then solve for x. Okay, number 13. Number 13 is a log. It's a natural log. So when we have natural logs, remember that your base is e. Okay, if you want to, you could rewrite this as log e of x minus 1 equals 5. But that's not required. If you see it, then you can just say, hey, I know that the base is going to be e. So I'm going to go ahead and erase this. Base is going to be e. These two here swap places, so it's e to the 5th power is equal to x minus 1. All right, you need your calculator for doing e to the 5th power. If you have a calculator that's similar to mine, we've talked about the buttons for that. You're going to type in 5 second ln. So e to the 5th power comes out to 148. 41315 Okay, that's just, again, not rounding yet. I don't round to the very end. Equals x minus 1. Now to solve for x, I add 1 to each side. So 149, 4132. This is when I can finally round because I'm done with that. Now, it says solve these, and then I'm going to ask that you tell me whether the solution is a solution or extraneous. So when it's log, you need to be able to plug that one in. So here we've got this. We're going to take it and put it back into the argument. So 149 and 4,132 10,000ths minus 1. Well, that's going to give me 148 with a little bit more. So that one there is a solution. Okay, so we have x is equal to 149, 4,132 10,000ths, and then this one here is a solution. Now we check if it's a solution when we're dealing with logs or natural logs. Exponentials, we have already talked about that one. We're not checking the solutions with those ones. Okay, number 14. On number 14, it's log. So I have got to take this log and possibly turn it into an exponential. I actually know that I'm going to have to, because when I look at this, there's a log on the left side, but no log on the right side. So I know I'm going to have to turn this one into exponential. Okay, but before I can do that, just looking at the left side, there's 2 logs. So I've got to condense it first. So I'm going to have log base 2 x times x plus 4 equals 5. Okay, I'm going to go ahead and simplify this piece here with distribution. So log base 2, the argument is x squared plus 4x equals 5. Okay, so now I've got to convert this into exponential. So I have 2 to the 5th power is equal to x squared plus 4x. 2 to the 5th power is 32 is equal to x squared plus 4x. Okay, this is quadratic, so I need it to be set equal to 0. So I'm going to subtract 32 from both sides. So 0 will equal x squared plus 4x minus 32. We have to factor that trinomial. So we've talked about using the diamond method or using the table to help us factor that. So x squared is equal to x times x. 2 numbers that multiply to negative 32 but add to 4. We have 1 and 32, but they won't make 4. I have 2 and 16, but they won't combine to 4. I have 4 and 8. They'll combine to 4. So I'm going to put 4 and I'm going to put 8. 4 needs to be positive, so I need the bigger number to be positive. Now using zero product property, x equals positive 4 and x equals negative 8. Now, we started out with the log, so we've got to check our solutions for both of these. Okay, so we're going to check the argument. So the argument here is x, the argument over here is x plus 4. So if I replace x with 4, it's positive. If I replace x plus 4 with 4, that's 4 plus 4 is 8, it's positive. So x equals 4 is a solution. Now with negative 8, log 2 of negative 8, the argument being negative 8, that would make it an extraneous solution. Remember, we cannot have a negative argument. Now what if I checked it on the other one, negative 8 plus 4? Well, that's still negative 4, or that is negative 4. It's still a negative, so that would still be extraneous. Okay, last one, number 15. Now I'm starting out with exponential. When I'm starting with exponential, all I need is the base and the exponent. Anything extra, I need to move. So I have a base, and I have the exponent. So that plus 1 needs to move. So I will have e to the power of x plus 4 equals 13 minus 1 gives me 12. Now it's exponential on one side, which means I'm going to have to convert this to a log. So I have log e of 12, or we can just write ln of 12 is equal to x plus 4. ln of 12, we plug that into our calculator. So we have 12 ln. Now I'm writing this down, but in your calculator, just remember not to clear it. Okay, and we don't round until we're all the way done. Okay, so now I'm going to subtract 4 from both sides to get x by itself. And then this is when I'm going to do my rounding. So x is approximately negative 1 and 5,151 10,000ths. Now I was not dealing with the log, so I don't need to check if this is a solution or extraneous, because I started with exponential. So that is it. Okay. All right. That is all that I have for this video. If you have any questions, please send me a remind. Okay. And I will see you all tomorrow.